Okay, it says we're recording. Oh man, I bet the internet here sucks. It's going to take forever to upload this. It probably won't happen till tonight, the recording be uploaded. So, what questions do you guys have?
Where do you want to start?
I'm trying to remember if I opened up the last review. Did I do that?
Yeah, you did.
I did. Oh, well, good for me. No, I didn't. I'll open it up now. The last review is now open. Exam 5 review. I don't know why it says Exam 5, but it's really final exam. So that only here, I should share my screen here so you can see really quickly. Share the screen. Okay, so exam 5 review, we didn't have 5 exams, but it's only chapters 6 and 25, which theoretically you guys should have a pretty good, hopefully understand that pretty well. I'm sorry I messed up those quizzes so badly. But I just barely opened that up a minute ago. So that's now open. And as far as reviewing for the test, I would say the exam reviews would be really useful. The old quizzes would be really useful. Your homework would be useful. I will open it right at 8 a.m. on Friday. It'll be 2 hours long. Guaranteed there will be a chi-square test question on there. That's my only guarantee. Probably be chapter 6, 90% chapter 6 question about Simpsons paradox. Everything else should be a review of everything else we've done. I'll probably 1 or 2 more hypothesis tests. So what do you guys feel weak on? I'm sure I'll ask you about parameters and statistics.
Can we go back over that one more time real quick? Because I seem to miss that on the last one. What's the difference between a parameter and a statistic?
Okay, who can answer that question?
Parameter comes from the population and statistics come from the sample.
That's exactly right.
Just remember the P and the S.
Yep. P and the S. Parameter, population, sample, statistic. What else? You know what we could do? I have this quiz here that I never gave you guys. I usually give it called the hypothesis test quiz. It's unpublished, and I wasn't going to publish it, but we could do that as a practice because
That'd be awesome.
my guess is most of you, let's see, can I do this without showing the answer? Let's see, maybe if I preview it. Oh, that worked out pretty good. The blankety blank is a statement we are trying to find evidence to support. So which of those 4 answers do you think is correct?
The null hypothesis.
Do you guys agree with that?
Yep.
Anybody disagree?
I want to say the alternative hypothesis.
Oh, we got a difference of opinion. We're going to have a poll.
We can't have class without a poll.
It's like tradition now.
I know. This is great interaction. One of those two is the correct answer, though. So let's do our poll. The blankety blank is a statement we are trying to find evidence to support. So this one, instead of agree and disagree, I'm going to put in null or alternative here. I need to move this so I can see. Null, alternative. Wow, we are definitely a divided group. How many people do we have here? 1, 2, 3, 4, 5, 6, 7, including me, which is really 6. I've got, 6 people voted. 1, 2, 3, 4 nulls and 2 alternatives. The correct answer is alternative. Hypothesis is the statement we are trying to find. So minority wins on this one. Let's see, that was Allie and Easton, I think, wasn't it? Good job.
Yeah, it's the alternative because like I was thinking like my mindset is like the alternative is often the thing that's like stated in the problem and not the null.
Yeah,
And so like that's
yeah.
normally what they're asking for.
We always assume that the null hypothesis is true unless there's evidence to suggest that it's not true. So yeah, so there you go. That was a good quiz question. Okay. So the correct answer is alternative hypothesis. Okay. Question number 2, the null and alternative hypotheses are given. Determine whether the hypothesis is left-tailed, right-tailed, or two-tailed. So here we're going to do a poll. This is our first 3 poll question here. Does it say left or right or one-tailed? I can't remember. Oh, it says left. Okay, so it's a greater than. So so is it left, right, or two-tailed? I'll show it again just in case. Okay, that's as long as you get. I guess need more information is another option there. 1, 2, 3, 4, 5. Who are we missing?
Bridger.
No. Oh, Bridger is here. Where are you? There you are, Bridger. Okay. Well, I don't know what happened to Bridger. I think Bridger just comes and walks away or something. Because he didn't vote here, right? Yeah. So you're all right. That was correct. Right-tailed test. Okay. Right-tailed test. Question number 3. According to the CDC, 15.2% of Americans experience migraines. A massage therapist feels she has a technique that can reduce the frequency and intensity of migraines. Determine the null and the alternative. Oh boy. Okay, so we'll call that A, B, C, D, and E. Obviously, none of the above should be at the bottom, but it changes the order. So, have you looked at that long enough to know which one's the answer? We're going to do another poll question. And, oh, did I do the same thing twice again? Wait a minute. Oh, no.
No, because they have P and mu, right?
P and mu, yeah. Oh, I didn't notice that. Okay, good. All right, so A, B, C, D, or E. Okay, so hopefully you have your answer. We'll do the poll question here. A, C, D. What do you guys think?
You're saying that none of the above is the E?
C is the none of the above. 4, 5, 6, 7. I think Elise didn't vote either. So Elise and Bridger, why aren't you voting? All right, well, majority wins. B was the correct answer. There you are, Elise. Okay. All right, question 4. According to the Center of Philanthropy at Indiana University, the mean charitable contribution per household among households with $1 million or more was 17,072. A researcher believes the level of giving has changed to determine the null and the alternative. I thought this was going to be a harder quiz than this. Okay, so once again, A, B, C, D, and E. We'll do it again. Except for I probably should let you see that longer. Are you all satisfied with your answer there?
Yeah.
Okay. A, B, C, D, or E.
Can you show the answers one more time? Okay.
There you go.
Is the greater than or less than supposed to be the not equal to?
It is.
Okay.
Okay, going back here. Oh, we've got 6 people answered. That's as good as we can get. Was Bridger one of those? Well, Bridger didn't answer again. We miss you, Bridger. All right, so D was correct. I thought this was going to be a harder quiz than this is. All right. Here, let's see what I got. Oh, actually, I didn't answer these. D, and I think that was B. Did I answer them all now? Did we get 100%? Oh, my answers are late. Yep, 1, 2, 3, 4. We got them all correct. All right, so the other thing we can do is we can go through either this or I have this spreadsheet or worksheet that I usually give to people. We can do it together. We did it last time. Maybe we'll start with some different ones. The problem is, I think there was a couple.
Review Simpsons paradox once too. I think I've got a pretty good understanding of it, but I mean, is there any way you can show us some more examples of it?
I don't have a lot of examples on that one that I can think of. We can go over the review sheet. Hopefully I got something on there. Homework. This is hopefully the right one. I hope I didn't give you my 2041. Some of these might be too hard because I have one for 2040 and one for 1040. But since you asked that about there first, okay, here's a good Simpson paradox. Okay, I think, given the following data, marital status and salary level, thousands of men, so these are thousands of men, what percent of single men have no income? What percent of men have no income? What percent of men with no income are single men? Oh, those are 2 questions. Here, we'll turn that into 2 questions. Sorry. So how do you do this one? That was nice and gave you all the totals there.
So you would,
You go 6,013 divided by the total number of single men, which would be 36,590.
36,590. Okay. What percent of men with no income are single?
Same thing, but divided by 8,843 because it's the other category.
13 divided by 8843. Okay. All right. Find the percent of men in each marital status group who have no income. Then find the percent in each marital group who have an income of 1,000 or more. What do the percents say? So probably the easier way to do this is to copy it into Excel so that we can do our calculations. Okay. So I'm going to erase all of these tables here. Okay, the question set here, I'm going to copy the question too, then we have to do this. No matter where I put that, it's always in the way. Okay, so let's ask the first question. What percent of men in each marital status have no income? So what would be so basically we're looking for the percents in this row. How would we figure that out?
Take that statistic divided by the 8,000.
Yeah. So we'll take this and divide it by that. I'm going to cheat and do it really fast, but I forgot about that F4. And hopefully when we add that up, it adds up to 100%. It does. Okay, so 67, almost 68% are single, 23% married, 8% divorced, and 1% widowed, essentially. Okay, then find the percent of each marital group who have an income of 100,000 or more. So we'll do the same thing here. So we're going to take this 1478, we're going to divide it by that 13,000.
you're on mute, Professor.
That's because I keep pressing the F4 button. Thank you. So I don't know what you heard there.
Oh, we can't hear you again.
Why does it keep doing that? I don't know. I didn't think I pressed that. Okay, so what do you guys think? So we figured out the percentages. Based on those two percentages, I'll make this a little bit bigger. What do you guys think?
They have a pretty inverse relationship.
What category is best to be in?
Married, I guess, if you're looking for money.
If you're looking for money, yeah, marriage definitely. 80%, yeah, of the 100,000 or more are married, whereas it's just 23. Single's definitely the worst because you're either no income or only 10%. Well, I guess no. Widowed. Well, widowed is about the same in both categories. Widowed and divorced are about the same, roughly. Married, you're definitely better off to be married, and you're definitely worse off to be single. So, all right, that wasn't really a Simpsons paradox rule, though. Yeah, divorced and widows doesn't seem to make a big difference there. That's interesting. We could do this, I think. Let's do this for the other two rows. I'm just curious. I did that without muting myself. That was great. So as we look at these, I'm just doing this just to make sure I didn't make any mistakes. But so widowed, there's just not very many people in that category that are in any of the categories. The divorced, roughly all are about the same. The marrieds, it's definitely better off to be married than in any other category, right? Because you're the highest one to make 1 to 50,000 and the highest one to make 50 to 100,000, and definitely the highest. And then single, yeah, single, you're the second highest to make any of those, I guess. I think this just explains we don't have that many divorced and married people in this group, comparatively speaking. Okay. That's not a good Simpsons paradox question, though. At least I don't think it is. We'd have to pull one up from the homework. It seems like there was one in the homework. I wonder if I could make this up. Usually they take somebody like Shaq and Kobe, and we'll talk about first half, second half, and so we'll make Shaq be one of two, and here I should do it this way. One of two, and Kobe's going to be 4 of 10, and then the second half, Shaq's going to be 6 out of 10, and Kobe's going to be 5 of 9. Let's see. So if we look at this in the first half, Shaq is 50%, right? And in the second half, he's 60%. And I don't know if this is going to work. Kobe's going to be 40%, and 5 of 9 is 45%. But when you add it up, I'm pretty sure, I should make sure, 5 divided by 9. Oh, 55%. Okay. So as we look at these in both halves, Shaq shot better, right? But when you look at when you add up the totals, this becomes 7. Shaq is 7 out of 12, and Kobe is 4 and 5 is 9 out of 19. Oh no, that didn't help. It's hard to come up with these in your head because it still looks like Shaq shot better overall. 58% versus yeah, I can't. Those are hard to come up with in your head.
If you would have done 8 of 19 on the for Kobe in the second half, I think that would have worked.
8 of 9, 8 of 19.
No, yeah, or 8 of 17 would even work. Because then you're looking at 12 of 27. No, never mind. It's still showing Shaq.
Yeah,
Shaq.
these are hard to come up with. It's really hard to come up with those. Those are just really special cases. But basically, the idea here is Kobe shoots worse than Shaq in both halves, but when you combine the data, he shoots better. That's an example of Simpsons paradox. And they give lots of examples in the book, but they're kind of contrived. I don't know. It's hard for me to think of those off the top of my head because the numbers are always kind of a weird trick. Maybe I should do it here. You know what if I did 3 of 10 and I don't know. Those are too hard to think of. You'll recognize it when you see it, hopefully. I don't want to spend too much time on hypothesis tests, but we can spend a few minutes. We can spend as long as you want. And I'm trying to remember, did we do we talked about Napster last time, didn't we? Yeah, because Allie didn't know what it was. Because she's too young. It's hard to believe that you're so young you can't remember Napster.
Sorry.
All right, here we go. Let's do this one. Fawn is a private investigator. She's taken a job at an insurance company. Insurance company has been paying out large money to workman's comp claims, and they believe some of the claims are fraudulent. The insurance company wants Fawn and her associates to run surveillance to determine if the rate of fraud is higher than what the industry normally reports. Specifically, they want to know if the incidence of frauds is more than 16%. They provide Fawn with a random sample of 47 claimants who have been diagnosed as unable to perform any physical labor beyond light housekeeping. They've asked Fawn to observe the sample, report back to them how many claimants are obviously trying to do things that are much more strenuous than light housekeeping, such as yard work, weightlifting at the gym, or other activities. Fawn and her team spend about 8 weeks completing their observations and report back to the insurance company that 14 of 47 claimants are not nearly as disabled as their diagnosis suggests. The insurance company wants to test the data. Which hypothesis test should they run? So what we're trying to do, I think there actually is enough information in this problem to do the whole thing. But we'll just answer these 4 questions because I don't want to spend too much time. So identify the numbers. Wants to do this one.
I can do this one.
Okay.
So I believe 16 is going to be your mu, 16%.
U equals 16%.
N is going to be 47.
Maybe I should keep them on the same line. I'll do it that way.
X is going to be equal to 14. And then X bar is going to be equal to 14 divided by 47. Wait. Is it supposed to be P and P hat instead of mu and X bar?
See, I'm the one asking the questions here. What do you think?
I'm pretty certain it's supposed to be P.
So this one is not mu anymore. It's what?
P?
P.
Yes.
This one is
P hat.
P hat. Okay. Any others?
Not that I can see on here. I mean, alpha would be 0.05.
Okay. All right. Should we gotta have a poll question. Do you agree or disagree with what he's got there? What Easton has? Four and 2 is 6. Still no Bridger. All right. That was correct. So I'm glad you changed your answer because, yeah, mu would have been wrong. Okay. Okay. Somebody besides Easton, is it categorical or quantitative?
Categorical.
Categorical. Okay. And who wrote? Oh, nobody. Wonder what that was all about. Categorical. Yep, that's correct. Which equation should you use? Now that's going to be the good one. I don't know if you guys have these memorized, or remember you can use your formula sheets for the acting like something's going on here. But can you guys tell me that without looking, or can you pull out your formula sheet so that you can look? Somebody besides Wes and Easton.
So we're using, we're looking for the hypothesis test. So it'd be Z equals P hat minus P over square root of P times Q divided by N.
P hat minus P divided by the square root of PQ over N. Is that what you said?
Yes.
Okay. Poll question says, where's my thing? Agree, disagree. We lost Bridger. Just waiting on Elise. All right, you guys are right. Okay, so what's the null and the alternative hypothesis? Somebody who hasn't answered. Seth, it must be your turn.
I'm just reading over the question again real quick. We're going to go for the null. P is equal to 16%.
Whoops. P equals 16%, you said?
Yeah,
Oh, my
16.
numlog's not working. That's why I did that.
And the alternative, I guess, P is not equal 16.
Okay, do you guys agree with that? Or anybody disagree?
Wouldn't you want your alternative to be greater than 16? Because we're mainly just worried that they have more fraud.
Yeah,
Right.
right there. There's your key sentence right there. More than 16%. So, yeah, does that make sense, Seth?
Yep, I just didn't read far enough, I guess.
Okay. All right, although that's the safe way to go in most cases. In most cases, except for the chi-square test, we almost always do a two-tailed. Normally. So if you're going to guess, not equals is a good guess. Okay? Oh, let me ask you one more question. Is my sample size big enough?
Yes, because it's greater than 10.
Are you sure?
Oh, wait. Because this is the NPQ one, right?
Yeah, NPQ has to be greater than 10.
Then yes, because the number is 47. And that's
Well,
greater than 10.
we need to do a calculation first before we can say that's for sure. So N is 47 times P is 0.16 times Q is 0.84 times 0.84. 6.31. Is that big enough?
Nope.
Not big enough. Okay, does that make sense? You can't just look at the 47. Got to look at all three of those numbers. So you got to make that calculation.
Oh, yeah, okay.
So no, it's not. And the next question is how big should it be? How would you figure that out? And PQ has to be greater than or equal to 10, right? Don't know the N, but we know that the P and the Q, so here N, times 0.16 times 0.84 has to be greater than or equal to 10, right? If we just say equals 10. So how would we solve for N?
Take the P times Q, take 10 divided by P times Q.
10 divided by 0.16 times 0.84 be 74. 75. So that would round to, so you'd always round up to 75. So you would need at least 75 people. Okay. Does that make sense, Allie?
Yes.
Okay. So
Will there be
75.
a question like that on the quiz or on the exam? How many will we need for certain tests?
Potentially.
Okay.
Okay, you want to do another one, or are you guys ready to go?
Can we do one more?
One more. Okay, administrative branch of the government developed a new strategy increasing the average of underrepresented minorities in management positions in the financial sector. They have data from 35 years before the strategy was implemented, and they consider that to be the baseline against which they will compare. The annual mean and standard deviation are known. The underrepresented minorities will consist of African Americans and Hispanics, but they are lumping those two groups together for purposes of the study. The plan has now been in place for 3 years, and they have new figures for those years. Boy, they aren't giving you any numbers here, are they? The type of hypothesis test. What type of hypothesis test should they use to compare the average of the past 3 years with the data from the previous 35? Wow. I don't even think you can answer those 4 questions. Did I copy them still? Okay, so there's no numbers to identify. We'll just go to B. Is the categorical data, is it categorical or quantitative? Now that's interesting because I didn't give you any numbers except for the 35 and the 3 years, I guess, but
Wouldn't it be quantitative because we're going to be measuring the mu?
right, we've got a mean and standard deviation, right? So it's going to be quantitative. Okay. All right. So even though there's no numbers, what would be your hypothesis or your test or equation that you would use? What would be the equation you would use?
Z equals mu minus mean divided by the sigma divided by the square root of n.
Okay, well, you must have done that from memory because you're on the right track, but that wasn't the right notation.
Oh, dang it.
Doesn't it need to be x bar minus mu divided by?
Yeah, x bar minus mu. That's better, but you were on the right track. Okay, and I'm impressed that you did that from memory. Okay, and we can't do the null and the alternative hypothesis because there's no information to even do. Okay. All right. Is somebody coming back? Oh, Seth left us and came back, it looks like. Or no, it was Elise. Welcome back, Elise. All right. So do you guys want to keep going or do you want to talk about other stuff? Because here's my only concern. It's a big concern. I know that the hypothesis tests are tough. The final is going to be on everything. It's not just going to be hypothesis tests. And I know at this point, sometimes I overemphasize hypothesis tests, usually because you guys are struggling with them. Is Janie still here?
I'm here.
Okay. So, what would you like to talk about? Because we can do this all day, or we can do other stuff. But I don't want you to think that the final is only going to be hypothesis tests.
Can we do some of the sample proportion examples?
What do you mean by that?
Like on the chapter 17, 20 to 22 review, the review 4.
You want to go over the review 4?
Yeah.
Okay. All right. Do you want to do the practice problems or just the review terms?
The practice problems.
Okay, so 16.10, a simple random sample of 654 young women found a mean BMI of 26.8. It comes from a known normal population with a standard deviation of 7.5. Find a 90% confidence interval. So how would we do that? Or better yet, what equation would we use?
Is this for anybody?
How about Janie first? Janie gets first dibs.
Hold on, I have to run and grab my formula sheet. So if someone wants
Okay.
to answer while I'm getting it.
Somebody besides Wes or Easton.
I was just reaching to unmute.
How about Elise? You haven't been talking too much, Elise. It must be your turn to talk. Are you there, Elise?
Yes.
All right. So do you know how to find the 90% confidence interval for this problem?
I'm still thinking.
I can do it if that's okay.
Okay.
All right, so you're going to take the mean, which is 26.8, plus or minus, and then like
Okay.
the
Before you do that, give me the equation.
the equation is the x bar plus or minus z alpha divided over 2 times the standard or sigma over or divided by the square root of n.
Sigma over the square root of n. Is that what you were going to say, Janie?
Sorry, I just got back, so I don't know
You
what I
got back.
missed.
Okay. I was just pulling up the equation, so I was asking if that's what you got. All right, so take it away, Allie.
Okay, so the x bar is the 26.8, and then be plus or minus, and the z alpha over 2 for 90, it's 1.645.
Okay.
And then you multiply that by the standard deviation, which is 7.5, divided by the number, or like the square root of the number, which is 654.
Okay. Well, that is correct. Now the question is, can you all type that into your calculator properly?
Yes.
Okay, so if I stick an equals in here, and that's the lower, and the upper, I'm going to change that to a plus. The 26 to 27. Okay, so, all right. I didn't ask you for a confidence statement, but given those numbers, Elise, it must be your turn. Can you give us a confidence statement?
So I can say we are 90% confident that the sample mean is between 26.31,
BMI
757.
is between 26.3, we'll round that to 2, and
27.28.
27.28. Okay. Yeah, BMI for women, whatever. Close enough. Okay. All right. So, Seth or Janie, I'm going to let you guys fight over this one. How would the margin of error change if you chose 95% confidence instead of 90% confidence?
The margin of error increases, doesn't it?
I'll be asking the questions here. Do you guys agree with that? Sounds like poll question time.
I'm already expecting the no.
Okay. Do you agree or disagree? Look at that, Janie. People are agreeing with you, and you agreed too. Who didn't vote? Oh, we've only got 5 of us left. No. Who didn't vote? Somebody didn't vote. There we go. Okay, look at that. Doesn't that make you feel proud that everybody agrees with you?
Yeah, it feels kind of good.
All right. See? All right. So there you are. So you should at least be 95% confident now, right?
Yeah.
All right. Okay. Oh, this would be a good one. I like this question here. A study of 16 students took a test comparing the mean difference of sensitivity. Use data below to compare to a change of 0, which is no change. Do a hypothesis test and confidence interval. Oh, this is interesting. Okay. So what if I gave you raw data? Could you come up with that? That's good. I will want to do this one because this is good. And this one actually has real data. Almost might want to put this one on the final. This is such a good question. Okay. So I'll let you guys take it away. How would you do this one? I'll let anybody answer.
Go ahead and write out your numbers.
Okay. What are the numbers we need?
N is 16. Yep. And then we need to calculate the your mu.
Okay.
Which would be, I didn't see what the average said down there in the corner.
Oh, it didn't. You have to find it yourself. Oh.
Let me go ahead and add it up real quick.
So mu is so you're saying that mu is the average of all these numbers? Here, I'll find it really quick.
Okay.
Okay.
Then the standard deviation of the sample.
What letter do we use for that?
S.
S equals, okay, so I'll just do the standard deviation really quick. Do you guys all know how to find that on your calculator? If I gave this one to you, could you do it?
I could use a refresher on how to find that, like what the formula for that is.
So, okay. Now, on a question like this, I wouldn't make you figure this out manually, but that's not a bad idea. Let's save that one for after this problem, but we can find this standard deviation by hand. That's a good question. But for now, we'll just go with the 0.226.
And I need to change that. That shouldn't be mu. That should be x bar, right?
X bar. Why is the X bar not mu?
Because it's a sample and not a population.
Very good. Okay, well done. I'm glad you caught yourself. Okay.
And then your alpha would be 0.05. Let's see.
Okay.
And then your x. I don't know if it's x or one of them has to be 0 because that's going to be what we use to create our null hypothesis. But
So something equals 0.
yeah,
Okay.
I want to say it's x, but
X equals. Do you guys agree? Is it X?
Disagree.
Disagree. Easton, you're such a curmudgeon.
then it should be the I can't even remember the name of that little symbol. The silly U.
The silly U. The MU. Do you agree with that now, Easton?
I do agree with that now.
Okay. The mu, yes, the silly U. Okay. Is there anything else? We'll stop there for now. Step number 2 is what?
Is this categorical or quantitative?
Categorical or quantitative. And it is
What is quantitative?
definitely quantitative. Step number 3.
Would you write out your hypothesis?
No. And the alternative, and I want Janie to have a lot of practice on this because she's going to ace the test, the final.
I feel like I'm gonna get this wrong. We would use, it would be the mu, right? Like we would start with mu.
I'll be asking the questions here.
Okay, I'm just gonna take a wild guess. Because if we're comparing to 0, so it'd be like mu equals 0.
Okay.
And then mu is greater than 0.
That sounded like a question again.
Yeah, it was.
You're supposed to be like, mu is greater than 0. So what do you think about that, Seth? Do you agree with her?
Sorry, one second. I'm just looking at it again. I don't know, honestly, right now. I'm still looking.
Allie, what do you think? Do you agree?
Yes.
Yes. How about you, Wes?
Yes.
How about you, Easton?
I do not agree
Why not?
because there's nothing in the question to say that we should just be looking for the right tail.
So what do you think?
I think it should be is not equal to 0.
Not equal to. Did I ask everybody?
No.
No. What do you think, Elise?
Yeah, I would say mu is not equal to 0 as well.
Oh, now we got 2. Is there anybody else I missed? All right. Well, I'm going with Elise and Easton. They're correct. It's not equal to because it doesn't say whether it's higher or lower. Okay. Does that make sense? Are you going to get that right, Janie?
Let's hope so. I thought I was right.
That was a good guess.
Thanks.
How about you, Seth? Are you going to nail it?
Yep.
Okay. Question number 4.
Pick a test.
Pick the test. And which test is it?
Would this be the t-test?
T-test. T equals
X bar minus mu, all of that divided by the sample standard deviation divided by the square root of n.
Okay. Agree with that, Janie?
Yes.
Yes, that was nice. That was affirmative. Yes. Okay. We're getting better. How about you, Elise? Do you agree with that?
Yes.
Seth?
Yep.
Would you, all right. Wes?
Yes.
All right. Everybody agrees. It must be right. Okay. Question number 5 is Seth, you know.
Compare to p-value, or find the p-value.
P-value. I guess we should find the t-square before we do that, though, right? All right. So Janie's going to punch us through the numbers.
Okay. So it's 0.10125
Here, I'm just going to click on it. Minus.
minus 0
Okay.
divided by S.
S, which is 0.226, right?
Yeah.
Divided by
Divided by the square root of 16.
Okay. So we've got a numerator divided by a denominator, which is 1.78. All right, so that's our t-score. And then, Seth, how do I find my p-value?
You would go to the table.
Okay. Let's see if I can open up the table here. Here it is. Which table?
For the t-score.
For the t-score. Okay. And then t-score, I need my degrees of freedom, so that was something else I probably should have added here. What's my degrees of freedom?
It's 15.
15. Okay. Whoops, not 51. 15. Okay, so 15. So we're looking at this line here, right?
Yep.
So, and I get a value of 1.789. So what's my p-value?
It would be between. You said it's 1.789, right?
Yeah.
Yeah, it's between 0.05 and 0.025.
Yeah. So you typically, when you're writing this, write it as 0.25 less than p-value.
Yeah.
Less than 0.05. It's kind of backwards on the chart, but anyway, yeah. So just flip it around. Okay. So step number 6 is what, Elise?
Compared to alpha.
To alpha. So we've compared our p-value. So our alpha, as we said, was 0.05. Still in the way. So we're going to compare that value to this value, and we're going to say what?
Reject or do not reject.
Reject or not. And you're going to say?
Do not reject.
Do not reject. Okay, do you guys agree with her? Janie, do you agree with her?
Yes.
How about you, Seth?
Yep.
How about you, Elise? No, not Elise. I already asked you. Allie, that's who I meant to say.
Yes.
How about you, Wes? That sounded like an anguished sigh.
Do not reject.
You said do not reject?
Yeah.
How about you, Easton?
I disagree. I think we should reject the null.
You're just disagreeing with everybody.
But my value is in between 0.5 and 0.0, like 0.05 and 0.025.
So what's the phrase that pays?
If it's low, reject the hoe.
If p-value is low, reject the hoe. Is my p-value low?
Not lower than your alpha.
Yeah, it is. It's
Oh,
less
it
than
is.
0.05.
Ah, son of a...
Oh, this is supposed to say 0.025. I did it again. Is that what messed you guys up?
Then we are rejecting them.
Yeah. Is that because I put 0.02? I should have put 0.025. You were supposed to stop me when you saw that typo. Yes. So we want to reject. Did you guys not reject because you thought it was greater than 0.25?
Yes.
Oh. Well, if it was 0.2, if it was greater than 0.25, yeah. Yeah, I did make a typo there. Yeah, but we're in between those two values, right? 0.025 and 0.05. Okay? So sorry, that was my typo. I didn't mean to do that. But yes, Easton was correct. Okay? So don't make that typo like I did. I'm sorry if that confused you guys. Yeah, 0.025. Okay? So the conclusion is what? Bring us home, Janie. Make us happy.
I feel like you'll be thoroughly disappointed in my answer. Oh, I know there was a phrase that we always use, but I can't remember what it is.
Oh, yeah. Well, besides the phrase that pays.
Yeah, not that one. Like there was one that we always used in the conclusion, like a way we worded it.
I'll help you out. We are, and I'll put not, let's see, or there is, or is not, I'll let you choose whether it's is or is not, evidence that, now you have to finish whatever we're measuring.
Okay. There is not evidence that there is not evidence in the difference of sensitivity of sun with and without eye grease.
Sensitivity of sun without eye grace. Okay. So you say there is not enough evidence, and maybe we should put enough evidence in here. There may be evidence, not enough. Okay. Now, should we go with our curmudgeon Easton right off the bat, since he always disagrees with everybody? Do you agree or disagree?
I disagree with this. I think there is enough evidence to suggest that eye grease creates a difference in sensitivity.
Okay. So how do we decide?
If you reject, there is. If you don't reject, there's not.
Yes. If we do not reject, there is not evidence. Otherwise, so the not goes with the not. Since we rejected it, there is evidence. Does that make sense, Janie?
Yeah, that does.
Okay. So remember, not goes with not. Otherwise, there is evidence. Okay. All right. So now, what about? It says do a confidence interval. We're going to do a 95% confidence interval. Who needs practice on this and wants to test it out?
I can do this.
Okay. What's the equation first?
So the equation that we're going to want to use for this one is going to be x bar plus or minus t times alpha divided by 2
T
times
alpha over 2, okay, times
s divided by the square root of n.
Okay. Now, in order to do this, we need one more thing in our numbers. What would be my t sub alpha over 2?
So wouldn't you go to the t table?
T table, and we need our degrees of freedom for our t table, right?
Yes.
Okay. So it's a 95% confidence interval. We need to find our t sub alpha. And remember, 95% confidence intervals are one or two-tailed.
Two-tailed.
They're always two-tailed, okay? So when we look at here, am I looking at the 0.05 column or am I looking at the 0.025 column?
0.025.
0.025. For 15 degrees of freedom. So what's my critical value?
2.131.
Okay. Would you have got that, Allie?
Yes, I would have gotten that.
Sweet. Okay. All right. So now do our lower and our upper and tell me what to do. So now that Easton's figured out this good stuff, who needs practice? Seth, you must need practice. What do I do here?
So we get x bar plus minus.
So x bar is what again?
It's the point 10125.
Okay.
And then we'd use the t statistic. That's
So we'll subtract it first. Okay.
minus 2.131. And then then multiply that by s, which is 0.22639,
Mm-hmm.
and then divided by the square root of n, which is 16 squared, or square root of 16, sorry.
Okay. All right. So I'm going to copy that. I'm going to paste that. I'm going to change that minus to a plus. Oh, okay. So, let's see. Who needs practice interpreting? It must be Wes's turn. Can you give me a confident statement?
We are 95% certain, or confident, sorry, that the average, I don't know how you'd want to word this, the average sensitivity to sun
The difference in
sensitivity
sensitivity to sun
with eye grease is between negative 0.01 or 2. I guess you could round to 2.
Yeah, we'll go a couple decimals.
Okay. And 0.222.
Okay, now here's the money question. Okay. Based on your confidence interval, does this confidence interval agree or disagree with the hypothesis test? And because that's a yes/no question, you have to answer why.
With the it does agree because it's different than 0. No, man. No, because 0 falls inside that range. Sorry.
Okay, so does it agree or not agree?
Well, it does not agree with the alternative because
Does
it
not
falls
agree.
within the 0. Falls
0
within
is in your confidence interval. Okay. Yeah, so we're looking at this. We got a negative and a positive here, so 0's in that interval. So the mean says that the eye grease makes no difference. This says there's no difference. This says there is a difference. Okay, so they do not agree. Okay, so well done, Wes. Now, does it surprise you that they don't agree?
Yeah, kind of.
Okay. What would be a reason why they would not agree? What would be another? So I love that you looked at the 0. That's perfect. You looked at your null hypothesis. Your null hypothesis said there's no difference. This, because 0's in here, says there's no difference. This says there is a difference. So why would they disagree?
Sample size? And the confidence.
Oh, actually, that's another question. We didn't ask if our sample size was big enough. Is the sample size big enough?
So for this one, because it's like mu and x bar, it's just n needs to be greater than 30, so it's not big enough.
Not big enough. Because n is less than 30. Okay, so our sample size is small, and it doesn't say that it's normally distributed, so that's a problem. Even if we assume that it was normally distributed, which, you know, it's not necessarily a safe thing to do, sample size doesn't explain why. Sample size might partially explain why these are
Well,
these
it
disagree.
does because the standard deviation is so big.
Yeah, yeah. Especially when you compare your x bar to your s, standard deviation is huge. But even with this huge, it's twice as big. But there's something else. So that's very astute that you're looking at you're comparing those. But there's still something else that I'm looking for.
Can we look at the equation for the upper and lower confidence interval?
Okay.
Do you need to have parentheses around this, or does it automatically know that it's doing the order of operations right?
I trust Excel's order of operations. It knows it right.
Okay.
Oh, actually, now that I think about it, you know what? Now that I think about it, we did the p-value wrong. I didn't catch that the first time. Our p-value is wrong. Why is our p-value wrong?
We didn't do 1 minus?
Nope.
We didn't double it?
We didn't double it. Because remember, our alternative hypothesis was does not equal. So that means we get to double both of those values. And so now, see, this is funny. It's 0.05 to 0.10, which means what?
You're not rejecting.
Do not reject, which means that there is not enough evidence, just like Janie wanted to say the first time. Okay.
I didn't doubt her for a minute.
So what do you think, Janie?
What am I feeling about being rejected?
Well, you kind of had the right conclusion, but it was wrong based on the wrong p-value.
Yeah.
This is why grading this test sucks so bad, because I will tell you what, if you had gotten the first p-value that we did, because I forgot to double it too, but it was good. That was kind of good, because this was a good check, because we were able to say, oh yeah, this is not significant, so why was that significant? And then we realized that we made a mistake on the p-value. So, because it was two-sided. Because our alternative hypothesis was two-sided, that meant we had to double the values here. So instead of 0.025 to 0.05, it's 0.05 to 0.10. Okay? Gosh.
So then we
Good thing we did the
not
confidence
reject.
interval. We would have screwed it up. So yeah, so in this one we do not reject,
Okay.
because you had to double the p-value, and now the p-value is greater than my alpha. So we would have not caught that. We did not catch that mistake until we did the confidence interval. Okay. All right, so we're going to do a roll call here. How confident are you in your abilities on the test, Easton?
97.
97% confident you're going to get a good grade. How about you, Wes?
I needed 93 in order to get an A in this class, so that's what I'm shooting for.
Are you 93% confident?
No, not anywhere close.
How about you, Seth?
I'd give myself an 85.
You're 85% confident. How about you, Allie?
Probably like 92.
92. Janie?
I'll give myself like an 80%.
80% confident. Elise?
I'll say 75.
75% confident. Oh, wow. I think I didn't mean to do that, but I think we went in almost descending order. All right. So we're out of time. I'm in a hotel and I'm almost positive the internet's going to suck. So I'm not going to upload this until very late tonight, maybe tomorrow, because I have 12 hours of driving ahead of me and I want to be home by 10 p.m. Hopefully. It's probably going to be closer to 11. So, so I will post this either late tonight or tomorrow. If it's not up by noon, can somebody text me and say, hey, we want to watch the video? Who wants to do that? Who wants to be in charge of that?
I will.
Okay. All right. Do you guys have any last questions before I let you go?
Nope.
Seth's already gone. All right. Well, it's been great having you guys, even if most of you aren't on a camera hardly ever. But we will see you all. No, we won't see you anymore. This is it. Okay. But I will say this. So I need to write the final. Text me if you have any issues with the final on Friday. It's from 10 to noon. No, 8 to 10, excuse me.
Can you also post the lecture notes for the last few chapters in there as well? Because we don't have those.
Oh, I forgot to do that. I'll try to do that. I can do that really quick. That won't take up a lot of bandwidth. Okay, yeah, I'll do that. Anything else? All righty then. Well, I will let you guys go, and we will see you all later. And I hope you ace my test.
Thank you.
Mm-hmm.
So I have an unrelated question so other people can leave. So for the last test, you said that you still had trouble like getting my submission for like the exam.
Yeah. I haven't had a chance to look at that yet.
Okay, because I just want to make sure that it worked with this new way that I did it, because if it doesn't, then I don't want to like have